Next, we have a truly fascinating session ahead. It's my pleasure to introduce Héctor Salvador, who will take us on a journey to explore the unique synergies between the sea and space in this keynote titled Exploration Without Bounds. Héctor is a submersible pilot at REV Ocean, and he has a remarkable background. Similarly to some of us, he studied aerospace engineering and worked at the European Space Agency. But he is one of the few humans, actually 1 out of 20, that have descended into the Mariana Trench, the deepest part of the ocean. With his extraordinary experience in both deep sea and space exploration, Héctor will share with us some of the connections between these two frontiers and how they're driving innovation and pushing the boundaries of human exploration. After his talk, you will have the chance to ask some questions through the app. So without further ado, please join me in welcoming Héctor Salvador to the stage.
Okay. Thank you, Laura. Thank you, everybody, for being here for this talk right after the coffee break. But, well, if I can piggyback on the previous presentation about Axiom Space, I think this is the new paradigm that we are experiencing everywhere, where commercial companies, private companies are taking over the challenge of exploration that before was just limited to government organizations. So if you allow me to jump from outer space to inner space, today I will take you to the other frontier of exploration, which is the bottom of the ocean. So as Laura said, I started in aerospace, in the space agency. But it was when I learned to scuba dive that I realized that there was all this world inside our own planet. 70% of our own planet remain unexplored. And we can find new species, like this one I put here on the picture. This one we found in 2019 in the Java Trench. And the biologists that were with us on the boat, they didn't even know to which animal kingdom this belonged. We are talking about an animal as tall as I am. Right? So we've been looking for aliens on the stars, and we forgot that 70% of our own planet still has a lot to discover. So it is true that the oceans have been basic for human development. They have been the base of our food chain, of our climate regulation, of trade since the very early ages. But oceans have also been scary. They have been the home of these sea monsters. They were storms. They were the pirates or the enemy that could come from the sea. So it has had this challenging relationship with humans. I like this picture of Costa Brava, where you can see that villages were built away from the sea. Yeah, you didn't go to the beach unless you really had to go fishing. But it was not a place that humans could go to. Because, as I said, it was dangerous, it was scary, it had a lot of unknowns. It's thanks to the development of technology, in particular, when in the 19th century, doctors start saying that not just the sea is healthy, but taking a bath every once in a while is healthy. That royals and the noble people start going to the sea to take these baths as a health treatment, and the invention of the train has opened wide access to the sea, making it accessible to general population, to the point that nowadays in Europe, blue economy, so talking about transportation and coastal tourism, employs 3.6 million Europeans with a revenue of about 400 billion euro a year. So also talking about how technology has helped humanity to reconnect with the oceans, we can see the exploration of the deep ocean. It has been taking steps as new technology was available. So in the mid of the 19th century, when the former warships start taking scientific missions, all the great explorations of the ocean, like the HMS Challenger in 1877, they start questioning what's the depth of the ocean. Because until then, until the 19th century, the ocean had been the surface, a surface of water. But nobody had interest in what was hidden underneath. So the Challenger starts taking the first measurements of how deep the ocean is, and then we see early 20th century with the apparition of the sonar technology after the First World War. They start to see some structures in the seabed, and finally, thanks to space technology, we have the first map that shows how complicated the seabed is. We can see how the bottom of the ocean is the source of the tectonic movements. We can see the the mid-ocean ridge where new crust is being created. We can see the big ocean trenches in the Pacific Ocean where the oldest crust is being destroyed by tectonic movements. And it's actually, I wanted to put this little overview of what we have underwater. We have the continents that are surrounded by the continental shelf, which used to be dry land until the last de-icing, and has an average depth of 50 to 80 meters. That's usually when you go scuba diving where you go. Then we have the big drop-offs that go to the ocean basins with an average depth of 3,000 to 4,000 meters. And then the deep ocean trenches that go almost twice as deep to almost 11,000 meters that only represent 2% of the surface of the planet. And that's the reason that they represent such a small percentage that they have remained unexplored. So in the 70s, in the 1970s, which is the golden age of human exploration of the ocean, where all the big governments started their manned submersible programs, like the US with the Alvin and the Trieste, France with the Nautil, Russia with the Mirs, etc. They limited the maximum depth to 6,000 meters because with 6,000 meters you cover 98% of the ocean. But why take that extra technology step just to explore 2%? Keep in mind that at the bottom of the deep trenches we have pressures, ambient pressure of about 1,200 bar, or 1.5 ton per square centimeter. Temperatures close to freezing point, about 1.5 degrees Celsius, and absolute absence of sunlight, meaning that the life as we know it on the surface of the Earth is not possible down there because it cannot be based on photosynthesis. So it had remained unexplored. There were only 2 missions that had gone down to the deep trenches in 1960, the Trieste with Don Walsh and Jack Pickard, and in 2012, the filmmaker James Cameron, that after making Titanic, he made his own submersible to go to Marianas Trench in this deep-sea Challenger. So it's in 2015 that an American explorer, Victor Vescovo, who had already been to the highest point on each of the continents, and who had also skied to both the North Pole and the South Pole, he decided to be the first human being to go to the deepest point of each ocean on an expedition that was called the 5 Deeps. And I think this is also a very interesting paradigm that is the same type of explorers or philanthropies that are financing this commercialization of both space and the seabed. So he came with this challenge, and the company where I used to work, we accepted the challenge of developing a vehicle. It would be the first vehicle in history that could dive repetitive times to these great depths. But when we accepted the challenge, we didn't even know what was the maximum depth of each of these oceans. We didn't even know where this deepest point was, and I'm talking 2015. So I find this amazing that this ocean has remained unknown until the 21st century. So the first challenge of the expedition was to follow all these deep trenches, measure them with multi-beam sonars mounted on the ship, and then take dives to each of these points to get the actual measurement, find out where the deepest point in each of the oceans was. But in parallel, we had to design the vehicle, a vehicle that has to go to a depth that we still don't know. So it was designed for 14 kilometers, just in case there were points deeper than Marianas. We have to keep in mind that with remote sensing from satellites, you can get a little bit the trend, but it's very difficult because of the amount of water to get accurate measurements of the actual depth. So as you can see, it's very similar to all the Bathys caves, even the Trieste. It has a metallic pressure hull made of titanium, where 2 persons will be going on the dive, and it's surrounded by these blocks of syntactic foam that gives it buoyancy, which is the force that will bring the vehicle back to the surface after the dive. The risk assessment for this mission was very important because, as I said before, the deepest submersible, government-owned, only goes to 6,000 meters. We were going to put humans twice as deep. That means that there was no rescue plan at all, right? So after 6,000 meters, you know you're absolutely alone, even more isolated than astronauts on the space station, because here we cannot wait on the seabed until another submersible comes and picks us up, knowing that there's not such another vehicle. So everything had to be designed with redundancy, with safety plans. As you can see here, the thrusters are isolated in nodes that are ejectable in case we get entangled on a fishing net or on a rope. The batteries, which are lithium-ion, also had to be ejectable in case they go into a thermal runaway during the dive. Eventually, it's like 2 submersibles in one frame to have full redundancy on the system. Here you can see the face of the beast when it was machined. And I like this picture because it showcases the contribution of the Catalan industry to this project. It was an American company building the submersible, but then they found out there was no companies in the United States that had the industrial capacity to manufacture these components with the tolerances it required to withstand a pressure of 1,400 bar. Right? So it was then when we found companies in Barcelona that were able to take the challenge. All the titanium was shipped to Barcelona. They built this beautiful machine. And here you can see the inside. I love this parallelism. As I said before, I started as an aerospace engineer, space systems engineer, and now I'm designing the life support systems of the submersible, which eventually is the same. We have to keep humans alive inside a sphere that goes to one of the most hostile environments on the planet. Instead of having a 1 bar pressure difference when you go to space, here we have 1,200 bar pressure difference, but still the human metabolism and needs are exactly the same. And finally, the vehicle was built and it was certified. I want to make a special emphasis on the word certified because certification, it's a lengthy process, it's expensive. We consider that about 60% of the total cost of the project was spent just on certification by an independent third party. And you also have to keep in mind that there were no rules for certification when this project started, because the rules stop at 1,000 meters. So it was a collaborative effort with the certification society to write what the rules would be to make a vehicle that could take humans safely to the bottom of the ocean. So we are very proud that it became the first deep submersible certified to dive to an unlimited depth. Because as I said at the beginning, we designed it for 14 kilometers, but then during the expedition, we found that the deepest point is only 11. So we overshot by a little bit, meaning that it's the first vehicle in history that can go to any point of any ocean of our planet. So this is a picture of the crew of that expedition. And here you have Don Walsh, the first human that went down to Marianas Trench in 1960. And I would like this picture to showcase the value of human exploration. I think humans tell stories. Humans can motivate the next generation. And we cannot forget the value of sending humans to these extreme exploration missions. I know for sure a robot can do it safer and can go quicker and is cheaper, but the robot will not be here telling you a story, and the robot will not inspire the next generation to do even greater things and make humanity advance. So just a little note about my dive. This is the southern arc of the Marianas Trench. The Marianas Trench is about 2,000 kilometers long. So the deepest point on the planet is Challenger Deep, with about 10.9 kilometers deep. But 130 nautical miles to the northeast, we have Sirena Deep, which is slightly shallower, just 10.7 kilometers, but is full of life. The bottom of Sirena Deep is full of bacteria that are absorbing their energy from the chemical compounds that are seeping through the cracks on the Earth crust in one of these deep subduction trenches. So they are not based on photosynthesis. They are chemiosynthetic bacteria, and that's the base of an entire ecosystem that lives down there in such an extreme environment that until the 21st century, it was thought that it would be impossible that any sort of life would live down there. Actually, when Don Walsh dove in 1960, and he came back and he said, I think I saw something moving, the scientific community questioned him. They said, it's absolutely impossible that there's life down there. So our mission was to dive to Sirena Deep and to take samples of this life and bring it back to the surface. Just a side note, here I put a transversal cut of Marianas Trench, because a lot of people think that the trench is like a crack that you go down with the submarine kind of bumping on the walls, but it's about 200 kilometers wide. So actually the slope that you can see is like a slope on one of the streets of Barcelona. It's not so extreme. So here we are in 2021. We went down on a dive that took us 4.5 hours just going down by the weight of the submersible, 4.5 hours sinking until we get to 10,700 meters. And then we can spend 4 hours on the seabed taking samples. This is one of the modules that we use to take scientific samples of the seabed. And this one had an incident, had an electrical problem. So the first mission we had was to find it and bring it back to the surface. So it was a search and rescue mission at 10,700 meters. So once we got it back, then we could spend time on the scientific mission, which was to get the first sample of these bacterial mats that live at the bottom of the ocean, that, according to some scientists, they could hold the key to the origin of life on the planet Earth. So this sample is already being investigated by 4 independent scientific institutes. After this 5 deeps expedition was finished, then the submersible, the technology that allows to open the door to every point of every ocean, started to be used for scientific purposes. What you can see here, this is the epicenter of the Fukushima earthquake in 2011. So we were able to take scientists to see firsthand with their own eyes what was the slide that created the earthquake in 2011, that created the tsunami. And we could also see the instability of the deep ocean there, the new cracks that are developing. So we go from the monsters, from these, tsunamis are unpredictable, to be able to take scientific samples of what's the origin of these high energy events. Just finally, this is a picture on the submersible. We have a REV Ocean. This is the deepest diving acrylic pressure hull ever made. It's about half a meter wall thickness, but completely transparent. It's made of acrylic plastic. So acrylic has this beautiful property that has the same refraction index as seawater. So you see through it as if there were no walls. And this works both ways. So the sea life approaches you because they see 3 humans sitting there in a bubble. So the encounters we have with marine life are amazing. I really remember these words from Jacques Cousteau, that reconciliation with the life is not possible anymore on the Earth, but it's possible in the ocean, because a shark will come and look at you with genuine interest. He doesn't see the human as a threat, as any animal on the surface of the Earth will see us, sadly. And this is also very interesting because acrylic, as a plastic, its resistance to pressure depends on water temperature. So we need to know what's the water temperature at depth before we are able to plan our dive. And for that, we use the Copernicus service. It's absolutely accurate. It's unbelievable when you go to 2,000 meters and you see that the Copernicus gave you a reading that is within 0.1 degrees centigrade. So congrats to whoever is working on that project. So just to summarize, as I started saying, technology has been making us closer to our planet. And I think the main value of space exploration is that we went to space to look back to Earth and to see what a beautiful water planet we have. And I think, let's say the 15th century was the century of exploration with ships, and the 20th century was the century of exploration of the near solar system. The 21st century, we have this commitment, we have this depth with our own planet to explore the oceans. So that's all from my side. Thank you very much. If anybody has any questions.
Thank you very much, Hector, for such an inspiring talk. That was fantastic. Thank you for opening us a little window into that magic world of yours underwater. All right, we have some questions coming here. And the first one is, what key lessons do you think is most urgent to apply for future research in both fields?
Well, if you allow me to be blunt about this, I think the most urgent lesson is that we have to be sustainable. The same as earlier this morning, we were talking about space debris and how every effort to explore the low Earth orbit is leaving debris behind. We have the same problem in the deep ocean. So the Marianas Trench, for example, that has several pools, one of the pools, the center pool, is completely contaminated by scientific tethers from robotic missions. Sometimes, some of them, they imploded, some of them, they left debris on the bottom, but it made it so dangerous for human exploration that you get entangled on this debris from scientific research that now is banned to go with manned submersibles into this part of the ocean. And we are talking one of the most remote regions of the planet. So I think any research has to be done sustainably.
Thank you very much. That's a very important topic for sure. All right, next question. Given the fragile ecosystems on both the ocean and space, how do we balance the need for exploration with the need for preservation? I think it's a similar question to the previous one.
Yeah, but a very interesting turn on this question, because it's true that we need to explore. We cannot stop. It's a human nature. It's in our genes. We need to continue exploring, but we have to do it first sustainably. And I think the key here is to share the data, right? If you can do a mission and you can share this data with other scientists, then they don't need to do the same type of mission and the same kind of debris just to get the same data set. So I think all the initiatives that are being done now worldwide to share information, to collaborate, are very important.
Totally agree. Thank you very much, Hector. That was fantastic. Thanks a lot.
Thank you.